In this video, we're going to look at some waveforms for a non-synchronous buck converter, or a classical buck converter, where we have a MOSFET in the control position and a diode in the freewheel, or the synchronous position. Now, actually what we have here is two MOSFETs, but the controller has a diode mode. And so if we look at the waveform of the switch node, we see that after the control switch turns off, the switch node voltage goes to 0. And this is detected by the controller, and it turns off that lower MOSFET, and now the body diode conducts. So now we're conducting with a diode. And I did this because I didn't want to build a separate little test board with just a diode. So this controller has this little diode mode, so I took advantage of it. So again, yellow is the switch node, inductor current, blue is the output voltage, and this is the PWM signal. So let's see what happens. So we're operating here in steady state. There's a certain amount of output current, certain duty cycle, output voltage. And what's going to happen here is I'm lowering the output current. And right here, where the current just starts to reach 0, right about there, we're going to see, notice how this waveform is changing. And we get this sinusoidal ring. That's pretty strange. What is going on there? And in fact, we see it actually kind of clamps here. Let me just pause it for a moment. What's going on here is after the lower MOSFET turns off, okay, the current is basically 0, and we have a resonant circuit between the output inductor and the capacitance at the switch node, which is the output capacitance of the lower MOSFET, or it would be a diode, and the control switch plus any other capacitance. And the initial conditions are no voltage across the capacitance, but we have a voltage across the inductor because it's the output voltage over the diode voltage. And so this resonant circuit rings. We actually start to have some little bit of negative current and that charges up the capacitance, and at the node it charges up the lower switch, discharges the upper switch, and rings the voltage up. Why do we clamp? Because that current's going negative through the body diode of the upper controller. Okay, and then once that current kind of reaches back to 0, now we've got another resonance. Now we're back to this resonant circuit. And so what we're seeing here is, again, examples of components that are not on the data sheet. The capacitance of the MOSFETs has a profound effect upon the operation of our circuit. So I'm going to let this keep running, and you'll see that as I lower and lower the current, eventually we get to the point where the ringing doesn't go all the way. There's not enough energy, and so as I increase the current, the ringing goes away. So now we're back to kind of continuous conduction mode. Here we're going into discontinuous conduction mode, and again we see the ringing at the switch node.